Ever wondered what would happen if our Earth decided to break away from the spherical status quo and embrace its edgy side? Picture this, Earth not as a ball, but as a cube. Buckle up because we're about to take a wild ride through the corners and edges of a cubic Earth. Now let's address a more down-to-earth concern, the age-old debate about the shape of our planet. Satellites and intrepid astronauts have treated us to breathtaking images of Earth's curvaceous beauty. Sure, from the top of a mountain, it might seem flat, but that's just a trick of the light, my friends. The curvature is undeniable when you catch a glimpse of the towering heights of structures like the Burj Khalifa. Let's rewind the clock about 4.5 billion years ago. Imagine a massive cosmic cloud of gas and dust, a nebula, collapsing and giving birth to a fiery star. This star, with its gravitational charm, pulled in everything nearby, forming a swirling disk of debris. Over time, these debris buddies collided, heated up, and voila! Planets were born. But why are they all spherical? Now let's visualize our beloved Earth as a cube. Forget the familiar sphere, we're talking about a planet with sharp edges and corners. How would this cube defy the laws of physics as we know them? First off, forget about the traditional equator. Say hello to temperate climates on every side. No more extreme temperatures or wild precipitation swings. It's a climate party all around. Well, it's all about gravity pulling from every side. The gravitational hug is equal on all fronts, pulling everything towards the center. That's the cosmic recipe for a perfect sphere. But what if we shake things up a bit? Now let's talk about gravity on our cubic Earth. Picture a Rubik's Cube in space, with the gravitational hotspots right in the middle of each face. The further you stray from the center, the stronger the gravitational pull. Standing tall won't be taken for granted anymore. Wander with me to the edges of our cubic Earth. The terrain? Barren, rocky, and dry, my friends. Why? Because all the water would be hogging the limelight at the center of each face. And the atmosphere? Well, it's either non-existent or too thin to support life. But hey, who needs air when you're at the center of a cosmic cube party? Now imagine you're the adventurous type. You decide to take a leisurely stroll towards the edges. Guess what happens? Gravity throws a curveball. Your center of gravity starts tap dancing beneath your feet, making it feel like you're walking uphill. Walking on a cube is like ascending a mountain, but with a twist, a gravity-induced twist. Now let's chat about the weather. If our cubic Earth decided to spin on an axis through two of its faces, the climate would be a roller coaster ride. The top and bottom faces, polar extremes. The other four sides, equatorial fiesta. Forget about the sun gracefully curving along the surface. It's going to smack those cube faces head on. Now picture this, Earth as a cube, but not just any cube, a spinning cube. If our beloved planet decided to twirl gracefully at its corners, each side would have a temperate climate. Say goodbye to the drama of extreme temperatures and wild precipitation swings. No more scorching heat or freezing cold. It's a climate party on every side. But, and there's always a but, waving farewell to our equatorial paradise means no more tropical rain dances or epic snowball fights. It's a trade-off, folks. Let's talk gravity. On this cubic Earth, gravity is playing a cool game. It's stronger at the center and takes a chill pill along the edges. So if you're conscious of your weight, aren't we all? The smart move is to measure it at the edge. At the center of each face, gravity is like, hey, I'm 1 gram, just like the good old spherical Earth. But venture to the corners and gravity says, let's keep it light, 0.646 gram. So someone weighing 100 pounds at the center becomes a featherlight 64 pounds at the corners. Just beware, the lack of atmosphere and water at these edgy locales might make you rethink that journey. Speaking of atmosphere, we've got an anomaly in the air. Earth's atmosphere is usually a well-behaved entity thanks to gravity. But on our cubic friend, things get quirky. With gravity pulling stronger from the center of each face, the atmosphere thickens at the center and gets a bit shy towards the edges. Breathing at the corners? Good luck with that. The lack of a welcoming atmosphere makes the edge a no-go zone for life. Plus, if our hypothetical cube matches Earth's volume, those sharp corners would rudely poke out beyond our atmosphere, creating a cold, desolate, and downright hostile neighborhood. Sure, you packed your spacesuit, but getting to the edge would require a special space vehicle. Talk about standing atop the world and a bit outside of it. Now let's come back down to Earth, or cube in this case. A cube-shaped Earth is more of a mind game than a reality check. Our physical laws raise an eyebrow at the idea of such celestial oddities existing in our universe. But hey, let's not shut the door on the wild possibilities of gravitational anomalies just yet. It's a cosmic what-if that sparks the imagination. Now let's rewind a bit. Remember when teleportation was just a fantastical idea, confined to the pages of science fiction? Well, buckle up, because we've seen teleportation become a reality at the quantum level. The point is that what we once deemed unimaginable often turns out to be the next frontier in our understanding of the cosmos. Sure, the notion of a cubic planet might sound like a stretch, especially when our current physical laws are singing a spherical song. But who's to say we won't stumble upon a cube-shaped celestial body in the vast expanse of space? So why even entertain the idea of a cubic Earth? Well, being open to new concepts, experimenting with hypothetical scenarios, and stretching the boundaries of our imagination is the first step towards turning these wild ideas into reality. Let's start with the flat Earth theory. Imagine, if you will, a disc-like Earth where the North Pole sits at the center. And hold your breath, there's no South Pole. According to the Flat Earth Society, the southern part is guarded by a colossal 150-foot ice wall, and no one has ever crossed it because, NASA supposedly frowns upon such adventurous endeavors. Now, just when you think it can't get more bizarre, flat earthers believe that our planet doesn't spin. Nope, it's not doing the cosmic twirl. Days and nights, they argue, are merely a result of the sun and moon cruising around in a 24-hour cycle. And if that wasn't mind-bending enough, get this. They claim that the sun and moon are a mere 32 miles in diameter. I can hear you scratching your head, and trust me, you're not alone. But hey, let's give credit where it's due. To the flat earthers, the photos from satellites and astronauts showcasing Earth's glorious curves are just doctored. They argue that the technology to tinge and skew is within the reach of multi-billion-dollar government-funded organizations. So, according to this logic, Kyrie Irving might be onto something when he says they lie to us. Now, before we plunge too deep into this flat rabbit hole, let's consider the evidence that our planet is indeed a sphere. Way back in 250 BC, the ancient Greeks were onto something. Armed with just 2 sticks, they positioned them 500 miles apart on the Earth's surface. If our planet were flat, both sticks should cast no shadow when the sun is directly above them. Simple, right? But no, the Greeks observed a shadow on the stick to the north. It's like a cosmic magic trick that happens only if the Earth's surface is curved, causing the other stick to be inclined. And here's the kicker, they used this simple method to calculate the Earth's circumference with just a 10% error. 2 sticks, a little bit of sunlight, and bam, we have evidence of a spherical Earth. It's like ancient geometry met cosmic enlightenment. In conclusion, while the flat Earth theory might stir up some lively debates in internet corridors, the evidence supporting a spherical Earth goes way back. And it's as simple as shadows and sticks. So next time someone claims the Earth is flat, remember the ancient Greeks and their ingenious shadow play. And that's a wrap. So what do you think? Share your thoughts in the comments below, and don't forget to like and subscribe to our channel for more.